So this is my example of an alcohol. So alcohol, I want to pay attention to where that OH is. And since I have a branch off of this carbon here and a branch off of this carbon, I want to look at where my branches are. Because my OH is right in the middle of that molecule, I want to essentially focus on whatever branch is going to come first in the alphabet. So since bromo is going to come before the methyl group here, I'm going to start on the left-hand side because my functional group is right in the middle. So I'm going to do 1, 2, 3, 4, 5 there. It's going to be how I number that alcohol. Okay. So I have a bromo group off of the second and then a methyl group. So bromo is going to come first. So I'm going to call it a 2-bromo. 4-methyl. And then I have 5. So 5 is going to be pent. So it is pentane. Drop the E and put the OL. And then I have to say exactly where that OH is located. So it's off the third. So I put a 3 dash in front of the pentanol. So just like a double bond or a triple bond, I need to write down exactly where that is located. Okay. So alcohols, OH, wherever that is, that takes priority. And then if you have a branch and you have a tie, you go with the alphabet, just like before. Okay, so again, alcohols, we're going to use the IUPAC system. You don't need to know which system we're using. The common name, it just becomes way too memorization driven. So it's really not important. And like I said, you could skip primary, secondary, tertiary alcohols. All right, so then we go to something called ethers. Now, ethers have an oxygen somewhere in the middle of a bunch of carbons. However many carbons you have, it doesn't really matter. But what matters is the oxygen is single bonded to 2 other carbons. So single bonded to 2 other carbons. We're not going to bother with the IUPAC system. The common name is going to be easier. So we're going to call everything an ether. Everything is going to end in the word ether. And then what you're going to do is essentially name what is attached to the oxygen as a branch. Okay, so I have 2 carbons here, so that's an ethyl group. I have 1 carbon here, so that's a methyl group. So I call it ethyl, methyl, and I go alphabetical ether. Okay. If I happen to have 2 ethyls attached, I do the di that I would do. You don't have any tris here. You only have dis. So diethyl ether is another way you can look at that. If you have a branch, you could also put branches on there. So again, ethers are pretty easy to do. So underneath your alcohol example, if you're doing this on a separate sheet of paper, write ethers. And ethers are kind of interesting molecules. They were the molecule or a group of molecules that they used to use for surgeries back in the 1800s, early 1900s to knock you out. They're kind of powerful. For an ether, you can do this little notation that kind of abbreviates a bunch of carbons. So you might see with parentheses a CH2 group multiple times. So that is another way you could possibly see an ether drawn. So CH2 just means I have a CH2 and a CH2 attached to that end. So I have 1, 2, 3 carbons. I have 3 carbons in here. So this is a propyl group. While this is 2 carbons. So that's an ethyl group. So all I have to do is put ethyl in front of propyl and then put the ether. So ethyl, propyl, ether. And again, if you had some kind of branch here, let's say this was a chloro and take off one of the H's, then you would put the chloro exactly where you would have it in the naming system. Again, if it mixed in there with a methyl group or something, you would put it between the ethyl and the propyl. So again, ethers are pretty straightforward in terms of their naming system. That one never seems to be an issue. All right, then we're on to what we call aldehydes. So these are a little bit more complicated. So I'm going to spend a little bit more time explaining a few of these. So aldehydes, what makes something an aldehyde is you have a carbon bonded to an oxygen, and you have a hydrogen directly attached to that carbon. So it's what we call on an end of a molecule. It's on the end of a molecule. Because it's on the end of the molecule, we don't need to tell anybody any numbers, because it will always be on the left or the right-hand side when you see it. We are going to use the IUPAC system name. Again, that doesn't matter that you know which one we're using, but we're only going to use one. And the reason we're using it is because we're just going to use the regular way of naming it. We're dropping an E and adding an AL at the end. Okay, so we're going to call it ethanol, methanol, over exaggerating. So the trickiest part to aldehydes is the fact that the first carbon is always going to be the aldehyde. So that is why we don't put a 1 in front of it, because of the fact that it will always be a 1. So kind of like a cycloalkene, where I said you sometimes, if you only have a double bond in a cyclo, one double bond, you don't see that one. Kind of the same mentality, So I have my first carbon is the aldehyde, and then everything from that. So even if I have a bromo and it takes priority in terms of bromo and the alphabet, this is still going to be the first carbon. That's still going to be the first carbon, okay? So you're going to drop the E and put an AL at the end. Drop the E and put an AL at the end. So aldehyde, so I'm going to pause here for a second and see if you can name it first, and then I will give you the name here in a second. So it doesn't matter if the aldehyde is on the left or the right in terms of when you see it on a example. So this is going to be my first carbon, even though I have this chloro here, and you would think you want to put chloro as lowest number as possible, and that is true. But the aldehyde is your functional group, so that's going to take priority. So I don't need to put the 1, but I do have a pent here. This is going to end in pentanal. So drop the E and then put an AL. So I have 5 carbons in a row. And then I got a chloro group here and a methyl group here. So the chloro is going to come first. So it's going to be a 4-chloro, 3-methyl, pentanal. So again, because it's on the end, we don't need to put that 1 there, okay? So that's, again, equivalent to what we've seen before. All right, so those are the first 3. All right, then we have ketones. So what makes something a ketone is I have a C double bond O somewhere in the molecule between at least two carbons, So what you're going to see in my notes is these R's. R's just mean a number of carbons, okay? So however many carbons I want. So the smallest ketone I could possibly make is a prop, because I need at least 3 carbons to make a ketone. Ketones are going to be like other functional groups like alcohols. I need to tell the reader where that double bond oxygen is located. So that is why I'm going to have numbers with the naming system. I don't have a number with the first ketone because there's only 3 carbons there. The only place the double bond oxygen could be is in the middle. So that is why you will not see a number system for this. We are using the IUPAC system because you do have some weird common names. So you might be familiar with acetone. It's a nail polish remover. You use it in a couple different applications. It's a pretty interesting solvent, but that would be something you would have to memorize. So this naming system is going to follow naming the alkyl group and then essentially dropping the E and putting a 1 on the end. O-N-E is going to be how you do ketones. So if I have 4 carbons here, it's called 2-butanone. Again, because I do have to tell the reader that it's off that second carbon. I can't really have a 3-butanone because that would just be flipping the molecule. So there's no such thing as a 3-butanone. But I did an example here of a pentanone. Again, because I have the double bond in the middle, I'm going to go with my substitutions like I did the other example. My bromo is going to come first, so I would start on the left-hand side for this example because the bromo comes before the chloro. But here again, I would need the number, so 3-pentanone, to say that I have it off of the middle carbon, So I'm starting a new piece of paper. So this is a ketone. This is a ketone that I'm drawing. So draw that molecule. Pause here for a second and see if you can name it. So this ketone that I drew has 6 carbons in a row. So it's going to end in hexane, drop the E, and then put the O-N-E on the end. I need to tell the reader where exactly that C double bond O is located. So that's going to be a 2 dash. And then I look at my branches here. I have a fluoro and a methyl. So I'm going to do a 5 fluoro and a 5 methyl. So I want to do just one more example for a carboxylic acid. Then we're going to take ourselves a break here just because, again, it's not a huge amount of information, but it's, you know, we're pushing the end of May here. We're pushing the end of May. All right, so carboxylic acids. Carboxylic acids is another end group, So we are not going to need any numbers for this one. So we're not going to need any numbers for this one. So a carboxylic acid is a C double bond O, so carbon double bonded to an oxygen, and then that particular carbon needs to have an OH. So it's not an alcohol because it's attached to the carbon that has the C double bond O. Because of that, it could only make one other bond. So that is going to be why it's what we call an end group. Typically you see it on the right, but it could be drawn on the left. It doesn't matter in terms of how it's set up. So carboxylic acids are going to name the alkane. You're going to change the E to an oic, and you're going to end it with an acid. So again, that H is what we call an acidic H. So depending upon however many carbons you have in there, you name it the alkane name, drop the E and put an oic, OIC at the end, and then call it an acid. So you could have, the smallest one you could have is methanoic acid. Then you could have 2 carbons, ethanoic acid, propanoic acid. You already know what ethanoic acid is. That's acetic acid. That is the acid you find in vinegar. So the other name for acetic acid is ethanoic acid. So again, going into the back stock room, trying to find acetic acid, and maybe it's named ethanoic acid. That's the most frustrating part of these naming systems. And again, the common names just become like a memorization drill. So for this example down here, I drew a pentanoic acid. So I have 5 carbons. So just like with the aldehyde, the first carbon is going to be that carboxylic acid. So I don't need a number system because it's always going to be the priority. It's always going to be the number 1 carbon. So then I have a fluoro off of the 3rd carbon and I have a chloro off of the 4th carbon. So again, same exact thing. I just want to go in order of the alphabet. All right, so let me draw an example of a carboxylic acid, and then we'll take ourselves a break. So again, carboxylic acid. All right. So see if you can name this one. So just like any organic molecule, I want to see if I have the longest chain, but I want all of my branches off of the longest chain. So that is why this is going to be how I do the numbering for the longest chain. So 1, 2, 3, 4, 5, 6, 7. So this is going to be a oops, heptanoic acid is what it's going to end in. That's an ethyl group, that's a methyl group, and that's an ido. We don't see a lot of idos, but I throw them in occasionally. So I have ethyl comes first, so that's off of the fourth. So 4 ethyl, 5 methyl, 6 ido. And again, because it's on the end, I don't need a number there. And that will always be the first carbon, always the first carbon. And that's nice because it's like, it doesn't matter what's attached, doesn't matter what's attached. All right, so if we could come on back, I just have 3 more functional groups to go through, 3 more functional groups to go through. And then you'll have some time to practice this, So we'll see where we are at that point. And the last 3 are not, I wouldn't say the most tricky, but I would definitely say esters are the weirdest of them all, meaning you really have to pay attention to how the molecule is organized. So this one, I'm going to kind of go a little bit slower and go through the examples I put in my lecture as well, just because of how complicated it is. So what makes something an ester is a C double bond O, and then you have an oxygen attached to that exact carbon, and then you have carbons on either side. So it's a C double bond OO. So sometimes you will see books put it as COO, meaning that has a double bond oxygen and then an oxygen attached to that carbon. So sometimes you see that kind of notation with this, with esters. So the IUPAC system is kind of weird in just how it has it organized. So we're actually going to use the common name for this one. So here is the trickiest part of the esters. You're going to have carbons off of the oxygen, and then you have carbons off of the C double bond O segment. So what I put in the box here is going to be what we call the longest chain. Even if it isn't the longest chain, it's going to be considered the longest chain. Okay, I'll make this a little bit bigger, So the C double bond O, and then however many carbons I have attached is going to be the longest chain. So that's going to be one part of the name. And then the oxygen end, well, however many carbons I have attached is going to be then named like a branch. So it's going to come in front of the name. So the ending part is going to end in OATE. So sometimes it is linked up with carboxylic acids, where you essentially drop the ick and you change it to an 8. So that's what you will see here with this naming system. So I have the longest chain. The longest chain for an ester is 2 carbons, okay, is 2 carbons. So I'm going to call it ethane, drop the E and put an OATE, OATE. So I am naming whatever is the C double bond O as that naming system at the end. Then whatever is attached to the oxygen end is going to be considered a branch. So I'm going to call that a methyl because I have 1 carbon there attached to the oxygen. So it's called methyl ethanoate, methyl ethanoate. So the trickiest part of this is understanding that that's the naming system that you have. So in this example that I gave in my notes, I have a C double bond O, and again, I have carbons going left and carbons going right. So no matter if this is a longer chain of carbons, it does not matter. Because it is only the carbons that are on the C double bond O side of the molecule is going to be the longest chain. And then whatever is attached to the oxygen end is going to be considered a branch. It's going to be considered a branch. So I have told you this before, I'm not going to do a branch off of a branch. So if I see it, if I put a branch, it's always going to be off of the longest chain. So that's a way for you to kind of recognize that. Since my bromo is over here, this has to be my longest chain. There is a way to do a branch off of a branch. I'm just keeping it very simple for this class. So the longest chain is 3. So it's going to end in propanoate. And I have a butyl group off of the oxygen. So this is my butyl group. And then I have a bromo off of what I call the second. So this is where it is tricky. The first carbon is somewhat in the middle of the molecule. So it's not on the end of the molecule like we typically see. The functional group is right here in the smack dab in the middle of this molecule. So this is going to be the first carbon. So the bromo is going to be the second. Again, you would probably get this correct no matter how you did it because the bromo is in the middle of that one. But do realize that the functional group is the number 1. So it's going to be in the middle of that molecule. So this one is a little bit more intense, let's say, in terms of the naming system. So again, this is your extra problem. So take a moment and see if you can name this one. See if you can name this one. So I would suggest with esters to maybe circle the side that has the oxygen to kind of maybe remind yourself that this is the branch. So this is going to be called butyl. Maybe try there first. And then start with the C double bond O and put a 1 there. And then start counting from there. Okay. So again, circle the branch and then go, okay, everything else is the longest chain. Maybe that will help. It's nice to see the branch is the one off of the oxygen. So it is kind of weird because it's kind of in the middle. So I have 5 carbons in my longest chain. So this is going to end in pent and OH. Again, pentane, drop the E and put the O8 at the end. Again, you kind of mix it in with the functional groups that we have. Because that is the first carbon always, you never have a number for this one. You never have a number for this one. And then I got a chloro group. Okay, that's my other branch. So who comes first in the alphabet? The butyl comes first. So the butyl doesn't have to be in front of the pentanoate. It's going to go with the alphabet. So that's why I did this example so that you could see that. So you should write the butyl first and then write the 3-chloro. Okay, so again, typically you see most of the branches are right next to the name, but you do go by the alphabet. You do go by the alphabet. So since because butyl comes before chloro, that's why you write it that way. So I would say out of all the functional groups, the ester is the one you kind of need to like look at a little bit more carefully, just because of it being so unusual with its naming system. All right, we only have 2 more. And amines and amides kind of go together. So once you learn amines, amides will just follow through. So it's kind of nice in terms of their naming system. And realize, again, those of you with some biology background, amines and amides, nitrogen is going to be, this is where we first see nitrogen is amines and amides. So amines is an NH2 group, and we are only going to do them on the end, even though you can put NH2 in different places of a molecule, and that does change a lot of its chemistry. But we are only going to name the ones that are on the end, just for ease of use. Again, this is just to introduce you to some organic chemistry. We are going to use the common name because it actually follows pretty nicely. The IUPAC is okay, but it's not, it has its moments. We are going to name the alkyl group as a branch though. So we're going to do it with a YL, and we're going to end it with amine. We're going to end it with amine. So it's going to tell you exactly what it is. So if I have 3 carbons attached to an NH2 group, it's going to be called propylamine. So if it's just a nitrogen with 2 hydrogens, it's going to be very straightforward of how you put it together. Where it gets more interesting is if you have something besides a hydrogen attached to the nitrogen. So let's say I had a methyl group directly attached to the nitrogen, and then I had my longest chain here. Okay, so I have 4 carbons here. So I need another naming system because I can't really use a number there necessarily. So what they do with amines and amides is they use a capital N as a number. Okay, so it's going to be used as a number. Because we are only going to be doing the nitrogen on the end, it will work very nicely. So if I have a branch somewhere along the longest chain, I then just follow it in terms of the alphabet. So I have 4 carbons in a row, so it's going to be called butylamine. So that's going to be the backbone of the whole thing. And then since I have a CH3 off of the nitrogen here, I'm going to do an N-methyl like it would be a number. So it'd be like a 2-methyl, 3-methyl. So the capital N is just going to work like a number. It's going to work like a number. So in the second example, I use the same number of carbons, but I put a methyl and then an ethyl group. So just like with a numbering system, ethyl comes first in the alphabet. So therefore, ethyl is going to be what I put first. I do N-ethyl, N-methyl. Now, if I happen to have an ethyl group somewhere off of here, that's fine. It would then have a number associated with it. The N is only suggesting that it's directly attached to that nitrogen. So that is why you see the N group there for that. All right, so let's draw ourselves another molecule here. Let's see if I could do something. So I have a nitrogen, I have a CH3 here, and then a CH2, 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 CH3. I have a CH2, CH, and then I have this methyl group here. I have a CH, there's my chloro, CH2, and a CH3. So like other functional groups, I'm going to start numbering with that carbon that's directly attached to the nitrogen. And I want to keep in mind, again, what's going to be my longest chain. If I have branches off of this, then that's going to be my longest chain. But you might see something where I give you, 3 things off of that nitrogen. You want to find the longest chain from that. So I have a butyl, I have a methyl, I have another methyl, and I have a chloro. So let's start with the easy part. And that is the ending is going to be a pentyl. So you name it, it's very weird. You name the longest chain as a branching system. So it's going to be a YL. It's very odd in how they have it. Again, this is just the easiest of the options we have for amines. Actually, amines have like 3 different naming systems. So it's absolutely crazy what you can do there. I have butyl, I have chloro, and then I have methyl. And the methyl, the reason I put this is to show you what if you had a methyl on the longest chain and what if you had a methyl on the end group as well. So just keep in mind the butyl is off of the end, so I'm going to use it as a number. So I'm going to start with that. Hopefully I give myself enough room. So N-butyl will take care of that branch. And then off of the 3rd carbon is my chloro. And then I have my methyls here. Okay, so just treat the N like a number. Okay, do you write the number first or the N first? I don't think there's a magic way of doing this. So I could do a 2, N dash dimethyl. I'm running out of room. So N-butyl, 3-chloro, 2, N dimethyl pentylamine. So what it tells the reader is off the 2nd carbon off of the longest chain, there's a methyl group, and there is a methyl group off of that nitrogen. Okay, so again, the N just works like a number, works exactly the same way. So it looks weird, but it follows all of the rules. And then again, the amine part, the longest chain, has the weird ending like a branch. That's the only other weirdness that you see. All right, so one more, and then we are done. We are done. And that is amides. Amides. So amides are going to follow exactly the same way as amines, other than the N group NH2 has to be directly attached to the C double bond O. So this one, again, is always going to take priority in terms of the system. It's always going to be the nitrogen end with the C double bond O. So for this one, it's going to end in amide. So that's going to be, again, from the name, it's going to be easy to do the difference between the two. So this is going to end in amide. The other one ended in amine. And just like with the nitrogen before, I'm going to use the nitrogen as my numbering system. So again, if I have this example here where I have 4 carbons attached to the nitrogen, that's my longest chain. So it's going to end in buta-amide, buta-amide. So again, you're going to call it butane, drop the E and then put amide at the end. I have 2 ethyl groups off of the nitrogen. So that's why I do a N comma N diethyl for that part. And because I have a bromo here off of the 3rd carbon, that's going to come first. That's going to come first. So 3 bromo N comma N diethyl buta-amide for that example. And then in my second example that I did in the lecture, I had 6 carbons here. I had 6 carbons in my longest chain. And then I put an ethyl group and a propyl group just to show you again that you're going to kind of mix and match, what I call mix and match. The ethyl comes before the fluoro group here, and then the N-propyl goes somewhere in there as well. So you always want to keep in mind that the N group is going to act just like a numbering system, and you just want to follow the alphabet rules for who comes first, second, third in the branching system, All right, so this is your last one for amide. Amide. Oops. All right, so see if you can name that amide. So longest chain is 5. Okay, longest chain is 5. So again, this is going to be pentane, drop the E, and then put amide at the end. Put amide at the end. And then you want to look at your branches. So I have an ethyl, I have a methyl, and I have a fluoro. So again, I just got to keep the alphabet in mind. So ethyl is going to come first. So I'm going to do it N-ethyl. And then off of the third carbon here, I have a fluoro. And then I have a methyl group. So it's an N-methyl. So like I said, amines and amides kind of go together. The only difference is one's going to end in amine, again, with a branching system with the YL in front. This is going to name like your typical alkane name and end in amide. And then the ends are just going to be whatever's directly attached to that nitrogen is going to be then, instead of a numbering system, you're just going to use a capital N. You're just going to use a capital N. All right, so thanks for your attention today. There are 2 worksheets, those of you at home. One is a gold color that has, it starts with the alcohols. It starts with the alcohols, so it has OHs. You could skip where it says, tell me if it's primary, secondary, ternary. But those are, again, I broke everything out into their groups. So like I have ethers and aldehydes together. I have ketones, carboxylic acids, and esters. And I have amines and amides together. And then this one here is the name. And then you got to draw it. So again, it's just going backwards in your head. So those 2 worksheets are the ones that I put for practice. And again, I know you're probably done with Go formatives, but I did create a Go formative just on identifying functional groups, because I'm going to put a couple questions on just what kind of functional group is it? So that's just a matching Go formative, and you will see your answers right away. And then on naming functional groups, I've just drawn a couple molecules and asked you to put in the name. So if you do go in there, it will, I have it set up so that you could see your responses right away. So you can see which ones you got right, which ones you got wrong. Okay. So again, I appreciate your attention today. Today was the last day of official learning of new organic stuff. So I'm probably going to check in with you guys on Wednesday and give you some more time to practice. Originally, I think I was going to give some kind of quiz. I might give you like a practice quiz that won't count for points to maybe see how this goes. But I know that today being the calc test, I think that's why a lot of people are missing. So again, have a wonderful day. And I will see you guys again on Wednesday, yes.
Have a good one.